Welcome to the spring edition of the eBeam Initiative's video journal called The Fine Line. I'm Jan Willis, facilitator of the eBeam Initiative, and with me today is Higashiki-san, all the way from Japan, from the Advanced Lithography Process Technology Department at Toshiba. Welcome, Higashiki-san.
Thank you very much.
You have been very busy this spring, going around the world talking about a new technology called Directed Self-Assembly, or DSA. So, could you tell us a little bit about how you got started with it? What was the motivation for you?
When I was 2005, I watched the R&D Center people presentation. I surprised the DSA technology in hard disk. Very good. Then I transferred to semiconductor technology. But in these days, DSA was only fingerprint patterning, random patterning. It was not available for the semiconductor, but very exciting. And it was my hobby. Then, in 2010, IBM and AMAT was presented in SPI or DSA technology. I was surprised. Then I focused on DSA in my semiconductor division.
Okay, so for our audience, some of them may not be very familiar with DSA. Could you just give a brief description of the technology and why it's unique?
DSA is a chemical phenomenon, not use such like big optical lithography, such like UVL. Pattern shrinking is problem is a big investment, but the DSA is cheaper than conventional lithography technology. Then I focused on DSA.
Okay. So besides Toshiba, who are the other major players that are working on DSA?
DSA technology, I hear that material vendors and tool vendors, truck vendors, is leading. But the other technology is not much for us technology.
So what are you finding are the top challenges for DSA to make it to production and be adopted? And is there any particular market segment that it's well suited for?
Top challenges is in DSA is computational lithography, I think so. Computational lithography is not different between the optical lithography. There are more complicated simulation will be needed. So, but no EDA vendor is prepared DSA simulation. But simulation is accuracy and turnaround time trade-off problem was not overcame.
So if you look ahead into the future, when would you predict at what logic node that DSA could be in production?
Yes, Toshiba is currently no logic, critical logic, but I guess logic need a contact hole technology and cut technology. DSA will first application will be a cut press or the contact hole. Of course, in future, lens pattern will be applied with DSA.
So to wrap up, for our eBeam listeners, is there any particular impact that DSA will have or might have on eBeam technologies?
Okay. DSA needs a guide pattern. DSA is complementary lithography with the other lithography. Guide pattern precision, lateral displacement is very important. EB writer performance will be needed for more high performances for guide pattern. Guide pattern patterning is very important for DSA performances.
That wraps up our spring edition of the Perspectives interview for the Fine Line Video Journal. I'd like to thank Higashiki-san for being here all the way from Japan. We look forward to future updates on DSA, but for now, thanks for listening.